गेट 2021 का काउंटडाउन शुरू हो चुका है एंड नाउ वी आर इन द एंड गेम।
इतने सारे चैप्टर्स, इतने सारे सब्जेक्ट्स, क्वेश्चंस लगाएं या थ्योरी पढ़ें, लॉट ऑफ थिंग्स आर गोइंग इनटू माइंड।
आप सोचते क्या पढ़े क्या छोड़े, कहां से पढ़े किससे पढ़े। Unacademy brings you a new crash course where you get complete syllabus with best solutions.
आपको मिलेगा हर क्वेश्चन का जवाब हमारे नए क्रैश कोर्स उम्मीद में।
एक कंप्लीट सीरीज विद फुल सिलेबस, होंगे 10 बेस्ट एजुकेटर जो मिलके बनाएंगे आपकी जिंदगी को आसान।
35 दिनों में कंप्लीट सिलेबस विद बेस्ट क्वेश्चंस।
सारे सब्जेक्ट्स बस एक चैनल पे, तो देर किस बात की। हो जाओ तैयार गेट 2021 को क्रैक करने के लिए।
तो मिलते हैं 20 दिसंबर को, लिंक इन डिस्क्रिप्शन।
लेट्स क्रैक इट। सबसे पहला क्वेश्चन या
एक ओवरऑल अपने पास सिनेरियो ये बन गया।
इलेक्ट्रिक फील्ड का फंक्शन क्या होगा?
Then it will be off.
गेट 2021 का काउंटडाउन शुरू हो चुका है एंड नाउ वी आर इन द एंड गेम।
इतने सारे चैप्टर्स, इतने सारे सब्जेक्ट्स, क्वेश्चंस लगाएं या थ्योरी पढ़ें, लॉट ऑफ थिंग्स आर गोइंग इनटू माइंड।
आप सोचते क्या पढ़े क्या छोड़े, कहां से पढ़े किससे पढ़े। Unacademy brings you a new crash course where you get complete syllabus with best solutions.
आपको मिलेगा हर क्वेश्चन का जवाब हमारे नए क्रैश कोर्स उम्मीद में।
एक कंप्लीट सीरीज विद फुल सिलेबस, होंगे 10 बेस्ट एजुकेटर जो मिलके बनाएंगे आपकी जिंदगी को आसान।
35 दिनों में कंप्लीट सिलेबस विद बेस्ट क्वेश्चंस।
सारे सब्जेक्ट्स बस एक चैनल पे, तो देर किस बात की। हो जाओ तैयार गेट 2021 को क्रैक करने के लिए।
तो मिलते हैं 20 दिसंबर को, लिंक इन डिस्क्रिप्शन।
लेट्स क्रैक इट। सबसे पहला क्वेश्चन या
एक ओवरऑल अपने पास सिनेरियो ये बन गया।
इलेक्ट्रिक फील्ड का फंक्शन क्या होगा?
Then it will be off.
हेलो, ओके, नाउ प्लीज सी। ऑडियो अभी ठीक है क्या? प्लीज लेट मी नो इफ द वॉइस इज ओके। हाँ, अभी ठीक है, ऑडियो ठीक है। नाउ प्लीज सी। गुड इवनिंग टू ऑल ऑफ यू। वेलकम टू Unacademy। ओके, तो till now we have completed transformer up to the harmonics part. Before moving further on the harmonic parts, first I thought ki we have to take a quick revision so that it will be very convenient when we go to the numericals. Okay, so today class is just a quick revision class. मुझे मेरी बात बहुत अच्छे से समझ में आ रही है, क्लियर है? बहुत बढ़िया। गुड इवनिंग एवरीवन बेटा, गुड इवनिंग एवरीवन। प्लीज शेयर दिस सेशन एज मच एज पॉसिबल। आपको ये सेशन को शेयर करना है बेटा, जितने ज्यादा लोगों से आप लोग शेयर कर सकते हो इस सेशन को शेयर कर डालो, ठीक है? अच्छा, मेरा नाम वरुण है। मैंने गेट एग्जाम को और कॉम्पिटिटिव एग्जाम्स को कई बार क्रैक किया हुआ है। More than 70K students I have already taught. Most of them got selected with a very good rank in a different PSUs, and they got a good rank in GATE also. Total teaching experience I have more than 10 years, and my subjects are electrical machine, control system, and digital electronics. जब भी आप, whenever you want to download an app of Unacademy, you can use my code that is VST101. This code will give you a 10% of discount. Is it okay? Now please see here, this is our team. आपको अपनी टीम के बारे में बता देना चाहता हूं. देखिए ये टीम जो है, दिस टीम इज गोइंग टू लीड फॉर द इंटायर इलेक्ट्रिकल पार्ट. ओके, सो इलेक्ट्रिकल स्टूडेंट्स के लिए ये बहुत अच्छी टीम है. हर सब्जेक्ट का हर एक इंसान बहुत अच्छा टीचर है. तो आपको ना इस टीम के थ्रू पूरा कंप्लीट गेट 2022 2023 और साथ ही साथ गेट 2021 की आपकी प्रिपरेशन कराने वाले. तो जो भी लोग अभी तक नहीं जुड़े हुए हैं अनअकैडमी से, वो जल्दी से जल्दी जुड़ जाए. ठीक है, सो आपको जुड़ने के लिए क्या करना है, बड़ा सिंपल सा कुछ स्टेप्स है, अभी मैं आपसे बताऊंगा. सून आई एम गोइंग टू टेल यू अबाउट द स्टेप्स अबाउट हाउ यू हैव टू ज्वाइन अनअकैडमी ऑन मोबाइल एप्स. ओके, नाउ प्लीज सी, देयर आर सम बैचेस आल्सो कमिंग ऑन, that is GATE 2023 ECE batch. So आपके जो भी friends ECE के हैं उनको आप बता सकते हो, and if anyone from ECE branch is watching this, they can also know that the batch is going to start at 21st of December for GATE 2023. Okay, and the major teachers are Vishal Soni sir, Suresh VSR sir, Siddharth sir and BV Reddy sir. Okay, now one more, Evolve batch for GATE 2022. If you observe Evolve batch, that is also for ECE, it starts from 21st of December and the major teachers are the same, that is Vishal Soni sir, Suresh VSR sir, Siddharth sir and BV Reddy sir. Now see, there is one more batch for electrical students. So most of the time students are interested in electrical na, as all of you are studying electrical machine here. Now please see, Evolve GATE for 2022, this batch is starting from 21st of December. So those who wanted to take admission for this particular batch, they must have to download the app and follow the sequences that I am going to elaborate further. Okay, the major teachers of this batch is Ankit Goyal sir, Ajay Gupta sir, Kaisar Hafiz sir, BV Reddy sir and Suresh VSR sir. Okay, there is one more batch for GATE 2023 and the teachers are same. The batch is also starting from 21st of December in both the languages English and Hindi. तो दोनों ही languages में start होने वाला है. अब आपने करना क्या है, बहुत ध्यान से देखिएगा. First of all, you have to download Unacademy app on your mobile phone. Okay, so for that just you have to type Unacademy learning app. This is the first and most popular app you will get very soon. Okay, then you have to install it. Okay, then you if you are from the technical background, you have to select GATE and ESE. Most of you are from the technical background, so you have to select GATE and ESE. Then you can choose plus, free course or special classes, whatever you want, up to your choice. If you are choosing plus, then you have to go for the subscription. Okay, then now please observe here, there are two types of subscriptions present, that is plus subscription and iconic subscription. ज्यादातर स्टूडेंट पूछता है सर ना ये प्लस सब्सक्रिप्शन में क्या है, तो देखो यहाँ पे लिखा हुआ है बेटा प्लस सब्सक्रिप्शन में you are going to get live classes, you are going to get crash course, weekly test, that is very important, doubt solving sessions for both English and Hindi, and rank improvement batch. Those students who have qualified GATE but they are not satisfied with their current rank, they can also join this in order to get a better rank for the upcoming years or upcoming examinations. Okay, now there is something more in the iconic batch. Please observe for the iconic one, iconic will provide you a personal coach. Okay, so you will get study planning, study booster sessions, okay, and personalized test analysis. Personalized test analysis will help you a lot in order to understand your difficulties where you are lagging. Okay, the points where you are not able to get the score. So that you will get from this personalized analysis, personalized test analysis. Other one is your printed and specialized study materials. Okay, so if you are going with the iconic will have a bigger boundary than the plus one. So iconic contains all the features of the plus along with these extra features. Now please see fee structure. If you talk about the fee structure, then this will be please observe for the 12-month plan you can go for 27,225. अब अगर मान लो कि आपको नेक्स्ट ईयर गेट देना है, इफ यू आर विलिंग टू राइट गेट फॉर द नेक्स्ट अपकमिंग ईयर, सो यू कैन गो विद दिस 12-month प्लान. और इतना ही नहीं है कि इफ यू आर टेकिंग द एडमिशन फॉर द गेट, यू आर नॉट एलिजिबल फॉर अदर एग्जाम्स which have the same syllabus as that of the gate. You are eligible to study each and everything whatever available in the gate and ESC section. Okay, सो अगर आप कोर्स लेते हो तो आप सब कुछ पढ़ सकते हो, जो भी अपकमिंग बैचेस आएंगे उन सभी के बारे में. फिर उसके बाद आप देख सकते हो यहाँ पे, लेट अस सपोज कि आपको जो है अभी 18 मंथ का प्लान का लेना है, तो आप 18 मंथ का प्लान ले सकते हो, जो कि गेट और ईएससी के लिए सोच रहे होंगे. फिर 24 मंथ का प्लान, अगर आप सेकेंड ईयर में हो, थर्ड ईयर में हो, तो उसके अकॉर्डिंगली आप चूज कर सकते हो व्हेन यू हैव टू राइट द पेपर. ओके, Iconic will have a different fee structure. If you go with the Iconic, then 12-month plan will be of 45,225, and for 24-month plan you can go with this 66,600. Okay, so again it is depending upon you, whatever most suitable for you. अगर मेरे से पूछोगे तो मैं ये बोलूंगा कि Iconic उन लोगों को लेना चाहिए जो अपनी खुद से स्टडी प्लानिंग नहीं कर सकते और बेहतर चाहते हैं. ठीक है, और प्लस जो है इकोनॉमिकल है, तो जो लोग इकोनॉमी वाइज सोच रहे, दे कैन गो विद द प्लस कोर्स. आई एम होपिंग कि यहाँ तक आप सबको मेरी बात समझ में आई है. ठीक है, अब देखिए ये एक स्पेशल सीरीज मैं चला रहा हूँ. दिस इज द स्पेशल क्लासेस ऑन अनअकैडमी ऐप, ट्रांसफॉर्मर न्यूमेरिकल सीरीज नेम्ड एज TNS सीरीज. ऑलरेडी in this series I have completed up to TNS series 5. Okay, so by tomorrow I am going for the TNS 6. TNS 5 तक की न्यूमेरिकल सीरीज मैंने कंप्लीट करी हुई ट्रांसफॉर्मर न्यूमेरिकल सीरीज में. अब आपका जो कल आ रहा है और जैसे जैसे दिन बदलते जाएंगे, ये एक दिन में 3 घंटे की क्लास मैंने रखी है. दिस इज इन हिंदी, बट हाउएवर इफ यू आर नॉट much comfortable in Hindi, then also you can watch, because the language I am using is very easy. Okay, in case if you found any difficulty, I can follow with your language. Now please see, ये मैंने 16 से स्टार्ट कर दिया था. ओके, ऑलरेडी आज भी आप लोगों को इसके बारे में बता देता हूं. इफ यू आर विलिंग टू ज्वाइन दिस, ओनली यू हैव टू फॉलो द बेसिक सीक्वेंसेस. यू हैव टू डाउनलोड द ऐप फर्स्ट, एंड देन you have to download the app, and then you have to just go with the plus free or special class subscription. You can use my code in order to get additional 10% discount. Okay, you can use my code, that is VST101, in order to get the additional discount. Free classes will have absolutely, this is just absolutely free. Okay, now please see, come to the next part. So I am hoping up to this each and everything will be clear. कोई भी क्वेश्चन पूछना चाहते हो तो पूछ डालो भाई. सर हिंदी में, प्लीज टेक अ मैराथन ऑन सिंक्रोनस एंड इंडक्शन. यस ऑफ कोर्स. अभी थोड़ा सा मैं हिंदी में भी बता देता हूँ. जिन लोगों को मैंने अभी इंडक्शन का कल क्लास लिया था, तो स्पेशल संडेज हैं, संडे को मैराथन आपकी होती है. जहां तक इंडक्शन हुई थी वहीं से इंडक्शन को वापस स्टेप अप करूंगा. कुछ न्यूमेरिकल्स कराते हुए नेक्स्ट संडे को आपकी मैराथन इसकी कंप्लीट कर दूंगा. ठीक है, तो ये इसी तरह से चलता जाएगा. फिर आपका सिंक्रोनस, फिर आपका डीसी, फिर सो ऑन. ठीक है, तो चारों मशीन में आपका लेने वाला हूं मैराथन सेशंस में. आज की क्लास आपकी जो है वो बस रिवीजन क्लास है, एंड दिस क्लास इज इन इंग्लिश. जहां पे आपको जरूरत हो वहां पे आप मुझे बताइएगा. दिस इज जस्ट अ रिवीजन क्लास. सो एक बार जल्दी से थंब बना दो, मुझे बता दो दैट एवरीथिंग इज कंफर्टेबल सर, नाउ यू कैन स्टार्ट योर क्लास. प्लीज एक बार जल्दी से थंब बना दो और मुझे बता दो दैट एवरीथिंग इज ओके सर, नाउ यू कैन स्टार्ट योर क्लास. जल्दी से शेयर कर दो भाई. कंप्लीट ट्रांसफॉर्मर रिवीजन, वेरी शॉर्ट ड्यूरेशन, वेरी शॉर्ट ड्यूरेशन. ठीक है, अभी तक जितना भी पढ़ा है दैट वी आर गोइंग टू टेक हियर. ओके, बहुत बढ़िया, मनीष वर्मा जी ने बना दिया है, वेरी गुड. सो आप लोग भी शेयर कर दीजिए सेशन को ज्यादा से ज्यादा लोगों को. ठीक है, इफ यू आर न्यू ऑन दिस चैनल, यू हैव टू सब्सक्राइब दिस चैनल इन ऑर्डर टू गेट all the upcoming videos of electrical machine by me. Okay, now please see. आपने कहा सर ट्रांसफॉर्मर का रिवीजन की बात कर रहे हैं, ध्यान से सुनते जाइएगा. फर्स्ट ऑफ ऑल आई एम टेकिंग विद द आइडियल ट्रांसफॉर्मर. ओके, सो first you have to remember about the polarity. Okay, so what we have to understand about the polarity, always keep in mind that dots will represent same polarity in mutually coupled windings. Okay, so this is just a revision. Please be focused. Let us suppose we have two windings here. Let us suppose we have two windings here. Okay, then if I am representing dot here, then other dot is this. These dots are representing same polarities of two different terminals of a mutually coupled circuit. Let us suppose we have a terminal 1, 2, 3, 4. So it just means 1 and 3 are of the same polarities at every instant, and 2 and 4 are of the same polarity. Okay, one more thing you have to always remember here, that transformer always works on a magnetic subtractive polarity. So if current enters through one dot, then at the same time current must leave through the other dot. This is the basic principle on which transformer works, because transformer always works on a magnetic subtractive polarity. That you can easily understand here. If the current is entering through dot, then it is creating an MMF. That MMF is you can say that flux is proportional to that MMF N1, and let us suppose this current is I1. So N1 I1. Yes sir. Similarly, if you observe here, at the same time, if the load is connected here and current I2 is flowing, then that current I2 flowing through n number of turn N2 is creating a flux. That flux, let us suppose phi2, is proportional to N2 I2. So always remember that MMFs are always a balance. Is it okay? So that shows a magnetic subtractive polarity. If the current enters through one dot, then current must leave through the other dot. सर एक बार फिर से बताओगे? Yes, please observe करिएगा बेटा, please observe करिएगा. Let us suppose we have a transformer. Okay, ठीक है सर, please observe, please observe. Let us suppose we have a transformer here, and the windings are wounded in this fashion. Say the windings are wounded in this fashion. ठीक है सर. Let us suppose we have a transformer here. बहुत ध्यान से देखना, बहुत तेजी से रिवीजन होगा, so you have to be focused. Okay, सब कुछ रिवीजन बस थोड़े देर में. Please observe करिएगा. Let us suppose we have a transformer and the windings are wounded in this fashion. So the way of winding is very important here. Now please observe. आपने बोला सर, let us suppose this will have number of turns N1 and this will have number of turns N2. So transformer always works on a magnetic subtractive polarity. Let us suppose the current is entering through here. Okay, so if the current is entering in this way, it will going to create a flux in this way. Okay, let us suppose this to be phi1, that is proportional to N1 I1, where I1 is this current. ठीक है बेटा, शेयर करना जल्दी से. यहां पर सर जो करंट बहेगी, the current flows through the N2 turns must be in such a way that if it flows, it will create a flux opposite to this flux. As per the right hand grip rule, you can know that, sir, in order to have the flux in this direction, sir, current must be here in this fashion. Yes sir. अच्छा सर, करंट अगर इस फैशन की होनी चाहिए तो डॉट्स का मार्किंग कैसे कर दें? इफ द करंट एंटर्स थ्रू वन डॉट, देन करंट मस्ट लीव थ्रू द other dot. Transformer always works on a magnetic subtractive polarity. One more thing you have to remember here, that terminal 1, 2, 3, 4. Out of terminal 1, 2, 3, 4, the terminal 1 and 4 are at the same polarities at every instant. However, 2 and 3 are with the same polarities at every instant. Is it okay? So sir, it can be observed here that V1 and the voltage at terminal 1 and 3 are in the same phase. Okay, and 1 and 4 are 180 degree displaced. Same if you observe here, 1 and 4 are in the same phase. However, 1 and 3 are 180 degree displaced. So always remember that terminals, or you can say terminal voltage, may or may not be in same phase, but always remember induced EMFs are always in same phase. क्या यहाँ तक मेरी बात क्लियर है? जल्दी से जरा इस सेशन को शेयर कर दीजिए ज्यादा से ज्यादा लोगों से. पहला पोलैरिटी का कंसेप्ट सर समझ में आया. दूसरा EMF equation. I'm moving very fast. Please observe. So EMF equation in transformer is EMF is equals to under root 2 pi F phi into N. This equation is called as a EMF equation in transformer, where phi m is the maximum flux. This is not a useful flux. RMS flux नहीं है. This is a maximum flux. Okay, sir. Third one is ideal transformer. So if we talk about ideal transformer, देखो पॉइंट वाइज करके जा रहा हूं मैं. Ideal transformer. If we talk about ideal transformer, then you can say, sir, V1 by V2 is equals to E1 by E2 is equals to I2 by I1, और we may write it as N1 by N2 first. बहुत ध्यान से सुनिएगा, सेशन को शेयर करिएगा, है ना, समझाता जा रहा हूं, बहुत ध्यान से रिकॉल करते जाइएगा. N1 by N2 is equals to A, that is equals to I2 by I1. Okay, you have to remember two things, sir. For an ideal transformer, there will be no voltage drop in the windings. Okay, yes sir. And the turn ratios and current ratios and voltage ratios are can be represented in this way. There will be no core loss, there will be no leakage reactance in the winding. Now ध्यान से सुनिएगा, अगर ideal transformer को represent किया जाए तो we can represent in this way. Okay, so the transformer is lossless transformer. The windings will have no leakage. The core is lossless. Okay, sir. This will be your E1, E2, or you can say N1, N2. Dots I am representing in this way. This will be your V1. This will be your V2. Current I2, current I1. There is nothing called as primary or secondary. The same transformer can be used for a step up or a step down purpose. You have to always remember that the load is connected onto the side where we are going to connect a load is called as a secondary, and the source side is said to be primary. Okay, now please see, up to this I am hoping everything is okay. बहुत बढ़िया सर जी, यहाँ तक आपकी बात अच्छे से समझ में आई है. बहुत फास्ट रिवीजन है, बहुत ध्यान से देखिएगा. One more thing you have to remember, sir, for an ideal transformer, V1 I1 is equals to V2 I2, and this shows KVA at input is equals to KVA at output. बोलिएगा. थैंक यू बेटा जी. सर डिजिटल बोर्ड पर, हाँ बेटा, कल से जो भी आपका सेशन होगा दैट इज ऑन बोर्ड. ओके, सो डोंट वरी अबाउट दैट. अच्छा जी सर, यहां तक आपका रिवीजन का पार्ट समझ में आया. थर्ड के बाद फोर्थ पॉइंट देखिएगा, प्रैक्टिकल ट्रांसफॉर्मर. प्रैक्टिकल ट्रांसफॉर्मर और एक्चुअल ट्रांसफॉर्मर कह देते हैं इसे. बेटर टू राइट एक्चुअल ट्रांसफॉर्मर. फोर्थ वन, एक्चुअल ट्रांसफॉर्मर. अगर हम एक्चुअल ट्रांसफॉर्मर की बात करें तो एक्चुअल ट्रांसफॉर्मर में आपको क्या याद रखना है? एक्चुअल ट्रांसफॉर्मर में आपको याद रखना है दैट E1 by N1, और यू कैन से सर इंपॉर्टेंट पॉइंट्स रह गए थे. फोर्थ वन इज योर EMF per turn for common flux, for same flux, EMF per turn must be same. So for same flux EMF per turn must be same. इसका मतलब क्या हुआ? E1 by N1 is equals to E2 by N2. Okay, ये अपने दिमाग में रखिएगा. Fifth one is your actual transformer. If we talk about actual transformer, then actual transformer core loss is present, permeability is finite, magnetizing current is needed in order to set up the flux in the core. बहुत ध्यान से सुनते जाइए. हाँ जी, बहुत ध्यान से सुनते जाइएगा. आपने बोला सर एक्चुअल ट्रांसफार्मर के केस में वी कैन गो विद फर्स्ट विद द एमएमएफ बैलेंस. सो इन केस ऑफ एक्चुअल ट्रांसफार्मर, always remember about the MMF balance. E1 by E2 is equals to N1 by N2. Okay, that is equals to A, but I2 is equals to I1 is equals to, you can say sir, from MMF balance. MMF balance से बात करें तो आप कह सकते हो सर N1 I1 is equals to N2 I2 plus of no load MMF. So since the transformer is practical, so we need a magnetizing current, that is no load current, in order to set up the flux in the core. So I1 is the phasor sum of I1 is the phasor sum of I2 by A plus of I0. That always you have to remember. Okay. Now for an practical or an actual transformer, आप कह सकते हो सर जो इलेक्ट्रिकल मॉडल होता है वो कैसा होता है. So this will is your fifth point. I am writing as a point wise, fifth, sixth point. Please see. Electrical model कैसा होता है of transformer. आपने बोला सर इलेक्ट्रिकल मॉडल की अगर बात की जाए तो, हाँ इलेक्ट्रिकल मॉडल की बात की जाए तो बेटा सर शेयर करिएगा. इलेक्ट्रिकल मॉडल कैन बी रिप्रेजेंटेड इन दिस वे: रेजिस्टेंस, रिएक्टेंस and core loss equivalent resistance. This is your magnetizing reactance. जल्दी से सेशन को शेयर कर दीजिए. सेकेंडरी साइड को अगर प्राइमरी साइड में रेफर करते हैं so we can represent in this way. So a practical transformer can be represented in this way. R1 and JX1 are the resistance and leakage reactance onto the primary side of the transformer. RC, JXM, R2 dash, that is your A square R2, and JX2 dash, you can also write it as A square X2 dash. Is it okay? Rest we treat the transformer to be a ideal one. So after that we treat the transformer to be the ideal one. This class is very important because this is a very quick revision of the entire things. Please see. Sir, the voltage here is V2, that we can write it as V2 dash, where this will be your number of turns N1 is to N2. Load can be facilitated here. Okay, so the current flowing in the load is say I2, and the current flowing here is I2 dash. This is the phasor sum of IC and IM. Always remember the transformer will have a magnetizing current 2 to 5% of full load current. Okay, this will be your I1 and this will be your V1. ठीक है, बहुत ही बढ़िया. Please share this session as much as possible. Okay, please share this session. Very important. Share this session as much as possible. Now please see. आपने बोला सर जहां पर A क्या है, where A already I have told you. A क्या है, आपने बोला सर A आपने बता रखा है N1 by N2, that is E1 by E2. ठीक है, अब जरा ध्यान से मेरी बात को सुनिएगा. आपने बोला सर यहाँ पर RC is the core loss equivalent resistance and XM is the magnetizing parameter. Because this I0 is only 2 to 5% of full load current, so we may use a approximate electrical equivalent model. So अगर exact data दिया हुआ है, you can go with the exact model, but as per the numericals asked in the different exam, you have to follow the electrical model as per the given data. Okay, so generally we use a first approximate model, and the approximate model can be represented in this way. Please see here. Approximate model. अगर approximate model की बात करें तो approximate model को हम कैसा represent कर सकते हैं, जरा ध्यान दीजिएगा बेटा. Approximate model can be represented in this way. शेयर करिएगा सेशन को. आपने बोला सर ये हमारे पास हो गया RC JXM, ठीक है, और R1 और R2 डैश एक साइड में कर लेते. ये इस ब्रांच को यहां बनाने की बजाय we can draw this branch here. So this will become A square R1 plus A square R2 dash can be represented as R equivalent on primary side. X1 and X2 dash can be represented as X equivalent on the primary side. Rest we treat the transformer to be the ideal transformer, so it can be represented in this way. क्या मेरी बात समझ में आई है? Share this session as much as possible बेटा. Please share this session as much as possible. क्यों कह रहा हूं शेयर करने के लिए? जोश बढ़ जाता है, पढ़ाने का मजा बढ़ जाता है. Now please see. In in case if we use approximate model, we can draw the approximate model in this way. अच्छा ये वाला model where we are going to use this model for the voltage regulation calculations. Okay, तो ये आपने कहा सर हमारे पास first approximate electrically equivalent model है. In some of that, sometimes we may neglect this I naught because this I naught is only 2 to 5% of full load current, and that model is said to be a final approximate electrical equivalent model. ठीक है सर, यहां तक आपको मेरी बात क्लियर है? प्लीज मेक अ थंब सो दैट आई नो यू आर गेटिंग ईच एंड एवरीथिंग. इलेक्ट्रिकल मॉडल आपको याद आया? बढ़िया. नाउ कम टू द नेक्स्ट पार्ट, दैट इज योर, हाँ जी, ट्रांसफॉर्मर लॉसेस. नाउ प्लीज सी हियर. दिस वन इज योर 6th point. 7th you have to remember. आज जब आप सोने जाओगे ना, आप इसी तरह रिकॉल कर सकते हो. 7th is your transformer losses. Please share this session as much as possible. So for transformer losses, you have to remember about the 4 things. First one is your core loss, also called as iron loss. So iron loss is further divided into 2 portions, that is hysteresis loss and eddy current loss. Eddy current loss, once the transformer is designed, is proportional to F square into Bm square, while hysteresis loss is proportional to F square F into Bm to the power x. Okay, F into Bm to the power x. Yes sir, where x is the estimates constant. ठीक है sir. Always you have to remember one more thing, that is V by F. So I am writing here, please see. If V by F ratio is not constant, if V by F ratio is constant, then always remember hysteresis loss is proportional to frequency, while eddy current loss is proportional to square of the frequency. In case if V by F ratio is not constant, then sir, first is your hysteresis loss is proportional to V by F, V to the power 1.6 by F to the power 0.6, and eddy current loss is proportional to V square. Okay, बोलिएगा क्या मेरी बात समझ में आई? Are you getting this thing? बहुत बढ़िया. Now please observe here. Next is your copper loss. Copper loss is also called as variable loss, and copper loss is proportional to I square, or you can say sir it is proportional to kVA square. So you can just write it as S square. Okay, so by using these two, either PCU is proportional to I square or PCU is proportional to kVA square, you can solve for the copper losses. Always remember that copper loss is calculated at fixed temperature. However, in an actual practice, whenever temperature changes, the copper loss may get varied. क्या मेरी बात अच्छे से समझ में आई है? बहुत बढ़िया. Share this session as much as possible. Next is your dielectric loss and stray load loss. So dielectric loss is a constant loss, occurs in the transformer oil and insulating materials of HV winding. Transformer oil serves two purposes. कौन कौन से? It provides cooling to the transformer as well as it provides isolation, electrical isolation. Okay, so you can also say it provides a dielectric strength to the you can say the gap between the body and the conductor. Okay, next is your stray load loss. Stray load loss is basically a load dependent loss. This loss occurs because of the leakage field. Leakage field creates a eddy current loss in the conductors, tank, channels, and other than core iron materials other than core are responsible for the stray load loss. Leakage field depends upon the load current. Always remember, it means stray load loss is dependent upon the load. Is it okay? So ये आपका complete about the transformer. One more thing you have to remember about the note point I am writing here. Please see. I am also writing here about the note point. Please observe here. If V by F ratio is constant, अगर V by F ratio constant है, then always remember about this straight line. This straight line is, the slope of this straight line is Ke dash. The constant is Kh dash. And this is your watt per hertz, 2 hertz. Okay, so this straight line where Kh dash is nothing but it is just kh into bm to the power x, and ke dash is your ke into bm to the power 2. Okay, so in that way you can also go to solve the number of numericals. This is very important. क्या यहां तक मेरी बात समझ में आई है? बहुत बढ़िया. चलो, आज मैंने यहाँ पर ओपन बोर्ड पे कोशिश करी है, तो देखते जाओ जरा यहाँ पे. आई एम होपिंग अप टू दिस पॉइंट एवरीथिंग इज ओके. नाउ कम टू द नेक्स्ट पार्ट, ट्रांसफॉर्मर लॉसेस, देन come to the efficiency of transformer, that is number 8, transformer efficiency. Okay sir, and regulation. So first let us talk about the regulation, testing, and then come to the efficiency. Sir, I am following the sequence in which I have already taught you. Okay, so 7th 8th one is your testing of transformer, transformer testing. So transformer testing will have OC test, SC test, Schumpner's test, and polarity test. So first is your OC test. The things which we have to be remember about the OC test is, please see here, बहुत शॉर्ट में बहुत जबरदस्त क्लास है, बहुत ध्यान दीजिएगा. सो ओसी टेस्ट में, ओसी टेस्ट इज कंडक्टेड ऑन HV side. No sir, LV side. We prefer to conduct it on LV side. Conducted on LV side and gives rated iron loss if conducted at rated voltage and rated frequency. Rated voltage and rated frequency. ठीक है सर, ये याद रहेगा हमें, बहुत ध्यान रखिएगा. आपने कहा सर यहां से हमको एक बात और याद रखनी है, इलेक्ट्रिकल मॉडल एंड हाउ टू कैलकुलेट द पैरामीटर्स. During open circuit test, we get about the RC and XM. Okay, and it is very easy to recall that RC is the voltage applied is VOC, the power flowing into the transformer under open circuit test is POC, and current is I0. This I0 will have further divided into IC and IA. So now rest is only the KVL, rest is only the basic network. Okay, I2 dash is 0. So sir, we can easily find RC by voltmeter reading, ammeter reading, and wattmeter reading. Then we can find IC, then we can find IM and XM. Is it okay? So I am hoping up to this everything is okay. बढ़िया. आपने बोला सर OC टेस्ट के बारे में पूरा ही लिख देते सर तो बढ़िया रहता, तो चलो मैं पूरी बात लिख देता. मैं कुछ बातें यहाँ बोल दिया हूँ और बाकी बातें यहाँ लिख देता हूँ, तो अच्छा लगेगा, ज्यादा थोड़ा नोट्स बढ़िया हो जाएगा आपका. OC test is conducted on HV side, and if the test is conducted at rated voltage, it gives rated, हाँ जी, core loss. ठीक है. Electrical equivalent model during OC test is this, where the instruments voltmeter, ammeter, and wattmeter reads the power input voltage applied to the transformer and no load current supplied. This will be your IC. Thank you beta. And this will be your XM. ठीक है. No load current is just 2 to 5% of full load current. One more thing you have to remember, that this transformer no load current is very highly lagging in nature, and therefore low power factor wattmeter is needed in order to measure the input power to the transformer during no load test. Okay. सर यहाँ से हम लोग क्या क्या निकाल सकते हैं? RC we can find VOC square upon POC. Once you have RC, you can calculate IC as VOC by RC, and once you have IC, you can calculate IM as under root of I0 square minus IC square. Once you have IM, you can calculate XM as VOC by IM. Okay, सर एक दूसरा टेस्ट हम लोग पढ़े थे, that is SC test, शॉर्ट सर्किट टेस्ट. शॉर्ट सर्किट टेस्ट में क्या है सर? Electrical equivalent model under short circuit test can be represented in this way of the transformer, okay, where this will be your R equivalent, X equivalent, and the current flowing is a short circuit current ISC, voltage is VSC. We always use a reduced voltage which is just sufficient to cause rated current under short circuit test. Okay, if the test is conducted at rated current, then it gives rated copper loss. Okay, sir. So from the short circuit test, we know about the R equivalent and X equivalent. R equivalent is, बताना मुझे तुम्हें मेरी बात समझ में आए तो, R equivalent is equals to PSC by ISC square. Once you have R equivalent, you can calculate Z equivalent. Z equivalent is, sir, Z equivalent is VSC by ISC. Once you have Z equivalent, you can calculate, हाँ जी बेटा, X equivalent. X equivalent will become root over of Z equivalent का square minus R equivalent square. Is it okay? बोलो बेटा. बढ़िया सर. Short circuit test और ये दोनों समझ में आया. Now come to the basic part of the polarity test and sharpness test. So third one is your back-to-back test. Back-to-back test is also called as sharpness test or heat run test, load test. Only one thing you have to remember, that two identical transformers are needed. Two same type of transformers or two identical transformers are needed. Okay. So इस केस में आप ये याद रखिएगा कि इसका एक demerit है. Back to back test demerit is two identical transformer is needed. That is sufficient, I think. Come to the fourth part. Wattmeter के बारे में बताया बेटा. For OC test we use low power factor wattmeter. However, for SC test we use normal power factor wattmeter. Okay, because the power factor for the SC during the SC test of the transformer is in the range of 0.5 to 0.6. Okay, now come to this back-to-back test. Difference between the transformer and the mutual. कुछ चीजों का जवाब देने का मतलब समझ रहे हो. चलो, बैक टू बैक टेस्ट के बाद लेट अस टॉक अबाउट द पोलैरिटी टेस्ट. सर, पोलैरिटी टेस्ट. सो इफ वी टॉक अबाउट पोलैरिटी टेस्ट, देन प्लीज सी हियर. बता दिया बेटा सूर्या मैंने तुम्हें. अगर छोटा है देन वी हैव टू यूज द नॉर्मल. जनरली वी यूज शॉर्ट सर्किट टेस्ट के लिए जनरली वी प्रेफर टू यूज अ normal power factor wattmeter. Now come to the polarity test. So in order to perform the polarity test, we just go in this way and find the polarities of the transformer. Please see here. You have to connect a portable voltage source here, say V1. Low voltage source definitely, because during the testing we don't want to do the core losses. Okay, so generally we use a low voltage source while testing the polarity. Only we have to use a voltmeter here. If this voltmeter reads lower than V1, then this suggests that these two are of the same polarity. Okay, so you can say in this way. It is very easy to understand. Now only you have to follow the voltmeter reading, and here I am connected on the HV side of the transformer. You can say, sir, in case if the voltmeter reading reads less than V1, then this suggests that the terminals where the voltmeter is connected are of the same polarity. So either you can represent the dots at this, or you can represent the dots at this point. So either it can be represented in this way, or it can be represented in this way. Now please observe here, these are the terminals 1, 2, 3, 4 where I have connected the ports. So you can say, sir, the terminal 1, 2 are of the same polarity and 3, 4 are of the same polarity. Or you can say 3, 4 can be represented by the dot, or 1 and 2 have the polarities without dot. Dot polarities means the terminals which have same polarities are represented by the dot. Okay. In case if we are getting V greater than this, so this suggests the additive polarity. Additive polarity means the polarity here and the polarity here are opposite. Okay, so additive can be represented in this way. Please see, it is very easy to conduct these tests and to find the polarity. 1, 2, 3, 4 terminals. So this represent that during the positive half cycle, if this is positive negative, then this is positive negative. Is it okay? Okay, sir. Okay, sir. So this is what we call the additive polarity case. Either it can be represented by this dot or this dot, or it can be represented in this way. So here it is representing that the dot terminals will have same polarity. It means 1 and 4 will have same polarity, and 2 and 3 will have same polarity. Okay, so dots ones are similar and without dots ones are similar. Okay, क्या यहाँ तक मेरी बात समझ में आई है? क्या यहाँ तक मेरी बात समझ में आई है? Okay, sir. Now come to the next part. Polarity test. Now please see. Up to the polarity test, I am hoping everything is okay. Now come to the voltage regulation. This is your the testing is your point number 8. Now come to the point number 9. Okay, so point number 9, please see here. Point number 9 is your voltage regulation. Very quick fast revision, please see. Voltage regulation. Okay, बहुत ध्यान से देखते जाइएगा बेटा. Now please see here. Voltage regulation can be defined as no load voltage minus full load voltage at the load terminals upon rated voltage. Is it okay? So it is basically the magnitude of the voltage drop in the transformer expressed as the percentage of rated voltage. You can represent here V no load minus V full load upon V rated. Okay, it can be represented as R per unit cos of phi 2 plus minus X per unit sine of phi 2. Whenever I am saying full load, then we must have to go in this way. Is it okay? Where R per unit, you have remember about the R per unit, R equivalent upon Z base, and X equivalent upon Z base is your Z X per unit. Okay, plus sign is used for the lagging power factor load, and minus sign is used for the leading power factor load. One more thing you have to remember, that R per unit is the per unit full load copper loss, and X per unit is the per unit voltage drop across the leakage reactance of the transformer. R per unit is also representing the per unit leakage drop across the resistance. Okay, per unit drop across the resistance of the transformer wires. Okay, now where phi 2 is your load power factor, so always you have to remember about this load power factor. Is it okay? अच्छा जी, बहुत बढ़िया sir. Can we write V no load minus V operating? In case if the transformer is a distribution transformer, then the distribution transformer is not going to operate at full load. Under that condition, we represent here no load minus V operating upon rated voltage can be represented as X times of R per unit cos of phi 2 plus minus X per unit sine of phi 2. But I am not going to call this to be the voltage regulation. Okay. The expression can be useful to find the relation between the output voltage under different loading condition, but we don't call this to be the voltage regulation. So voltage regulation I have represented here. Is it okay? ठीक है sir. Now please see here. One more thing you have to remember about the condition for zero voltage regulation and condition for maximum voltage regulation. So condition for zero voltage regulation is the power factor of the load cos of phi 2 must be equals to X per unit upon Z per unit, and that should be leading. Zero voltage regulation is only possible at leading power factor load, and the condition at which voltage regulation is maximum depends upon the designed parameter of the transformer X and Z. Similarly, condition for maximum voltage regulation. So condition for maximum voltage regulation is, you can write sir, cos of phi 2 is equals to R per unit upon Z per unit. Sir, how to remember this? It is very easy to remember because R by Z is normally we study about the power factor. Okay, so the power factor at which voltage regulation is maximum is R by Z. However, for 0 is a special one, so you can write it as X by Z. So it is very easy to remember. Always remember that maximum voltage regulation is only possible at lagging power factor load. Maximum voltage regulation is only possible at lagging power factor load. Is it okay? And what is maximum voltage regulation? Also, you have to remember about the maximum voltage regulation. So what is maximum voltage regulation? I am writing here. Please see. What is maximum voltage regulation, sir? Maximum voltage regulation is maximum voltage regulation is maximum voltage regulation is Z per unit. For finding percentage, you have to just multiply by 100. Is it okay? बताइएगा बेटा. Repeat, sir. Repeat कर दे रहा हूँ. Please see here. Condition for zero voltage regulation and condition for maximum voltage regulation. In order to remember about the condition for maximum voltage regulation, you all are aware that cos phi is equals to R by Z. So it is the normal case. Maximum voltage regulation is only possible at lagging power factor, and the case is R per unit upon Z per unit, or you can also write it as R equivalent upon Z equivalent. However, a special case is zero voltage regulation. So it is very easy to recall that zero voltage regulation is X by Z. Normally we remember about the R by Z. 0 is for X by Z. So you can now easily remember the conditions for maximum and zero voltage regulation. This is different for the different transformers. It totally depends upon the R and Z values of the different transformers. So it depends upon the design parameters of the transformer. ठीक है, बताइएगा. (2020) के लेक्चर्स आपके नेक्स्ट मंथ से स्टार्ट हो जाएंगे. 2022 वाले जो लेक्चर्स हैं वो आपके नेक्स्ट मंथ से स्टार्ट हो जाएंगे, पेड वाले भी. ठीक है, ओके. नाउ प्लीज सी, मतलब जनवरी से स्टार्ट कर दूंगा. नाउ प्लीज ऑब्जर्व बेटा, अप टू वोल्टेज रेगुलेशन आई एम होपिंग कि एवरीथिंग इज क्लियर टू यू. नाउ कम टू द एफिशिएंसी. दिस इज योर 10th one. You have to remember the transformer efficiency. Now please see here. Always remember that transformer efficiency is output upon output plus losses. One can say, sir, kVA x kVA cos phi 2 upon x kVA cos phi 2 plus of pi plus of x square PCU FL. Now sir, what is this S? S is a kVA, kilovolt ampere reactive or volt ampere reactive. This is the rated kVA of the transformer. What is this X? X is the loading factor. X is the loading factor, where this loading factor can be represented as, हाँ जी बेटा, operating current upon full load current, or you can say, sir, kVA operating upon rated kVA. Let us suppose we have a 100 kVA transformer, but the transformer is working only at 50 kVA. So the loading factor is 0.5. Is it okay? Okay, sir. So we can go with the loading factor relation to find the efficiency. One more thing about the losses. Please see here. From the same expression, we can go for the losses also. So Pi, very important. I am writing it as a note point. Pi plus x square PCU FL of a transformer is equals to x times of rated kVA into cos of phi 2, that is load power factor, 1 upon per unit efficiency minus 1. So if the transformer is given to you and the efficiency of the transformer is mentioned with the two different loading condition at two different power factor or maybe the same power factor, then you can find the full load copper loss and iron loss by using the two equations. Okay, so this is very important, very useful for competitive exams, very useful for competitive exam. Okay, आपने कहा सर ये वाली बात भी आपकी समझ में आई, प्लीज ध्यान दीजिएगा. Efficiency, now we are always interested to get the maximum efficiency. So condition for maximum efficiency is, now please see here, condition for, this is the 10th point, efficiency part. Condition for maximum efficiency. Now, condition for maximum efficiency, you have to remember here that operating copper loss is x square PCUFL, where PCUFL is full load copper loss, is equals to iron loss. Or these are the conditions. I am writing the conditions at which efficiency is maximum. Operating current is equals to rated current. I am writing it as part 1, part 2, part 3, so on. So current at which efficiency is maximum is Pi by PCUFL. Again, you can say, sir, we have the loading at which efficiency is maximum. Okay. Come to the third one. KVA at which efficiency is maximum. That is rated KVA अंडर रूट ऑफ, बोलिएगा बेटा, बहुत जरूरी है कि आप बहुत ध्यान से सुने, PI by PCUFL. So we have the rated KVA also. Please let me know if you are getting each and everything. Please let me know if you are getting each and everything. Given question में होगा X. Yes. देखो, let us suppose I am saying we have a transformer having an efficiency of 98% at 3/4 of full load. It means the efficiency at 3/4, the loading is 3/4 of the full load, efficiency is 98%. Again, I am saying the same transformer will have the efficiency of say 99% at full load unity power factor. So full load means now the loading factor is equals to 1. So you can use this formula to make two different equations, and you can easily solve to find Pi and PCUFL of the transformer. Is it okay? Now please see. Ishan Singh, is it okay, beta? Now come to the next part. KVA at which efficiency is maximum. Maximum efficiency. We are also interested to know about the maximum efficiency. So maximum efficiency is KVA at which efficiency is maximum into cos of phi 2 upon KVA at which efficiency is maximum into cos of phi 2 plus of 2 Pi. Always remember, iron loss is equals to operating copper loss to be equals to iron loss in order to have a maximum efficiency. ठीक है बेटा, ये याद रहेगा. One more thing you have to remember, in case if they are asking about what power factor at which efficiency is maximum. So I am also writing here as a condition number 4. Cos of phi 2 is equals to 1. This is also the condition for maximum efficiency. So in order we have a fixed power factor, however variable loading condition, then this is the case. And if we have a variable loading condition along with a variable power factor, then you can also choose cos phi to be equals to 1. Is it okay? Is it okay? Okay, sir. Now these are the conditions at which efficiency is maximum, and we have a maximum efficiency condition. One more important expression is all day efficiency. So whenever they are asking about the all day efficiency, it should be in energy, because when we are talking about 24 hours, so kilowatt hour, it means we have to calculate in terms of energy. So all day efficiency is can be calculated as kilowatt hour output in 24 hours upon kilowatt hour output in 24 hours plus of kilowatt hour iron loss in 24 hours. क्या मेरी बात समझ पा रहे हैं? Plus of kilowatt hour copper loss in 24 hours. Now one thing you have to remember about the all day efficiency, and that is your iron loss. Please see, in case if I am saying that the transformer is on no load, when the transformer is on no load, then no load losses are occurring. Output is 0, core loss, copper loss is 0, but the no load loss is still you can say present when the transformer is on no load. When I am saying transformer is off, so when I am saying transformer is off, it means there is no losses. It means input side is off. And when I am saying transformer is on no load, it means transformer is operating, the transformer input is connected to the supply, but output load is absent. क्या मेरी बात क्लियर है? इस बात का बड़ा ध्यान रखिएगा. Where I am writing here also, kilowatt hour output is kVA into x into cos of phi, and kilowatt hour copper loss is x square into PCUFL. You have to multiply by number of hours also. Have to multiply by number of hours also. क्या मेरी बात समझ में आई है? Now Up to this, I am hoping each and everything is clear. Come to the next part. Come to the next part, that is part number 10. Part number 11. Come to the next part, part 11. So 11th part is auto transformer. So auto transformer. In case of auto transformer, you have to remember that percentage saving in copper material. I'm starting from here. Percentage saving in copper material compared to two winding transformer. Compared to two winding transformer. Always remember that is equals to 1 upon A auto into 100. Now what is A auto? You have to remember here, A auto is HV side voltage by LV side voltage of auto transformer. A auto is HV side voltage by LV side voltage of auto transformer. Sir, can you represent this auto transformer? So better to start with representation. चलो मैं यहाँ पे रिप्रेजेंटेशन से चालू कर देता हूँ. Please see. We have a auto transformer here. So the number of turns are NH, voltage is say VH, okay. Number of turns are NL, voltage say VL. Now one thing you have to remember here, the current flowing onto the input side say IH and the current delivered to the load say IL. You have to represent the dot here, and you have to remember one thing, that if one current enters through dot, then the other current must leave the inductor through dot. This is the basic principle on which transformer work, that is magnetic subtractive polarity. So if the current is entering through dot here, say IH, and this current is IL, then by the KCL at this point, you know the current here, that is equals to IL minus IH. Always remember, if one current is entering through the dot, then other side coil current must leave through the dot. Okay, transformer always operate on a magnetic subtractive polarity. Okay. Now from here you can say, sir, this is an auto transformer. Can we use this transformer as a step up or a step down? Yes. It doesn't matter where you are going to connect a load or source. The same transformer can be used for step up as well as step down purpose. आपने बोला सर यहाँ से अगर हम देखें तो for common flux, because the entire turns are going to be linked by the same flux, EMF per turn is same. So you can say, sir, VH by VL is equals to NH by NL, and that is what we called A auto. That is turn ratio of auto transformer. One more thing you can say, from MMF balance. From MMF balance. You have to remember this. From MMF balance, you can say, sir, if the entire turn is NH and this turn is NL, so the remaining portion of the turn is NH minus NL. These turns are called as a series winding turns. So NH minus NL turns carries a current IH, and that current is equals to no load current taken by this transformer. So under no load current, under no load condition, the entire current flows through the NH turns. So you can say, sir, NH into no load current I naught plus of, you can say, sir, under loaded condition the demand will be NL. NL turns will have a current IL minus IH. Okay. In case I am saying NHIH is equals to NLIH, and this will be cancel out. So this will become NHI naught plus of phasor sum plus of NL IL. Is it okay? Yes, sir. So it can be observed here, in case if the load is current is 0, then NHIH is equals to NH I naught. Okay. In case if I naught is neglected, then NHIH is equals to NL IL. And from here you can say, sir, VH by VL is equals to NH by NL is equals to IL by IH, that is called as A auto. Okay, generally we treat the auto transformer to be the ideal auto transformer, and we put all the practicalities on one side, then we treat the ideal. For ideal, you can say I naught can be 0. Is it okay? So that you have to remember for an auto transformer. In some of the book, it is represented as K auto. So whenever you are observing K auto, always remember that is equals to 1 by A auto. So it means LV by HV they are representing. Okay. Always represent here A auto whenever you are going to use the formula as per I have shown you. Okay. Please observe here. आप बोलोगे सर यहां से आपका पहला पार्ट था सेविंग in copper material. So some important formulas you have to remember. Compare to two winding transformer of same rating. ठीक है ना. बस आज भर और इस पे है, इसके बाद आपको सिर्फ बोर्ड पे क्लासेस मिलेंगी. So 1 upon A auto sir into 100. So this will be the percentage saving in copper material. Okay sir. One more thing you have to remember about the power transferred conductively and power transferred inductively in auto transformer. So you can say sir conductive power transfer to total power transfer conductive power transfer to total power transfer in auto transformer. Please see, conductive power transfer to total power transfer in auto transformer is 1 by A auto, and this is the reason behind the saving in copper material. Third, you have to remember about the inductive power transfer. So inductive power transfer is also called as magnetic transfer. Inductive power transfer to total power transfer. Inductive power transfer to total power transfer in auto transformer is A auto minus 1 upon A auto. That is always less than 1. Okay. So आपने कहा sir we can easily find out the inductive power transfer and conductive power transfer in auto transformer, where you have to remember that A auto is defined as NHV by NLV, where A auto is defined as NHV by NLV. So you have to remember this. In case if you are representing K auto, then the formula is going to be changed as K auto into 100. So you have to keep this in your mind. I am hoping up to this everything is okay. Bolo beta Sachin ji, Vinayak ji, बढ़िया. Now come to the this is your auto transformer. Auto transformer is your point number 11. So point number 11 is having 1, 2, 3 points. So I am representing the fourth point here. Fourth point is kVA capacity of auto transformer compared to two winding transformer. In case same amount of material is being used, then you can only use this formula for a additive polarity as A auto upon A auto minus 1 into 100. But this formula is only valid for a yes, of course. Here I am representing, please see. The maximum, how to find the maximum auto transformer rating. Please observe beta. I am going to show you, Vinayak ji. kVA of auto transformer to kVA of two winding transformer when same amount of material is being used can be represented as A auto upon A auto minus 1. You have to remember one thing here, that for maximum kVA capacity of auto transformer, A auto should be close to 1. Okay, so A auto is close to 1. Unity लिख देता. It means sir, let us suppose we have a two winding transformer. Say the two winding transformer is of say 100 by 200 volt, and we have to connect the two winding transformer as an auto transformer. So we must have to connect the auto transformer for a maximum kVA capacity in such a fashion that A auto should be close to unity. And in order to get A auto to be close to unity, if we have this to be winding, say A, B, C, D, then please see here, this is a two winding transformer. We have to connect it as auto transformer. So we must have to connect it in an additive polarity and A auto close to unity. So for additive polarity and A auto close to unity, you must have to select CD here and AB here. Okay, so you can say, sir, the additive polarity shows this, the total voltage here will be 300 to 200. If you are using 300 to 100, then you are not getting a full utilization of the connection. It means the kVA capacity will be lower. In order to have the maximum handling kVA capacity, you have to choose the winding connection in such a fashion that A auto should be close to unity. Now if you write here, that will become, sir, add these two, so this will be 300 upon the HV side of the two winding transformer, that is 200. So if you are choosing 3 by 2, then you are going to get the maximum kVA capacity. Instead of this, if you are choosing like say 300 by 100, then you are going to get lower kVA handling capacity. So we always use additive polarity in order to get the maximum kVA capacity, and A auto should be close to unity. Is it okay? Clear, Vinayak? Share this session as much as possible, bhai. Very important. Now please see, you have to remember about the percentage impedance of auto transformer to percentage impedance of two winding transformer. Whenever we are connecting a two winding transformer as an auto transformer, we can go by the first one is kVA capacity. Second one, you can also go by the percentage impedance. So for a percentage impedance of auto transformer to two winding transformer, you can write, sir, kVA capacity of two winding to kVA capacity of auto transformer. Always remember the percentage impedance of auto transformer decreases comparative to the two winding transformer. Okay, whenever we are connecting a two winding transformer as an auto transformer. One more thing you have to remember about the losses. Percentage losses when auto transformer is running at its rated to percentage losses in case of two winding transformer, when two winding transformer is operating at its rated. Let us suppose this is of 100 kVA, then you can say, sir, we can calculate the kVA capacity of this. That kVA capacity of this will become 3 by 1 into 100. So you can say, sir, 300 kVA. Hai na? Yes, sir. So kVA capacity of auto transformer, if this is 300, so it means if it is operating at 300, then the losses in case of auto transformer connection. 2, if it is operating at 100, two winding transformer is operating at 100, then losses at two winding transformer is represented as, Haji beta, bahut dhyan se dekhiye, actual losses will remain same. However, the per unit losses or a percentage losses are different. That is kVA capacity of two winding to kVA capacity of auto transformer. Also, you have to remember about the efficiency. Whenever we talk about the full load efficiency, then it will be very easy to understand 100% minus percentage losses. So if you know about the full load efficiency of a two winding transformer, and you have to find the full load efficiency when the transformer is connected as an auto transformer, then you can go by the percentage losses relationship. Is it okay? बोलिएगा, शेयर करिए भाई, शेयर करिए. बहुत ज्यादा बढ़िया क्लास है ये. Best है कि आपको you are getting each and everything in the very short. Okay, now please see, come to the next part. Sir, I am going to start by next month. Okay, अभी सब कुछ free चलेगा. Next month से start करूंगा paid course for 2022 and 2023. Now please see, come to the next part, that is your short circuit current. So per unit short circuit current in case of auto transformer to per unit short circuit current in case of two winding transformer. Always remember that the greatest, you can say, the disadvantage of connecting two winding transformer as auto transformer is a short circuit current, and this current is increases because of the decrement in the percentage impedance. Is it okay? So that is why we never connect a two winding transformer as a auto transformer. Okay, whenever we have to design auto transformer, we always try to go with a fresh one. Now please see, short circuit current can be represented as kVA of auto transformer to kVA of two winding transformer. Is it okay? Yes, sir. So the times by which KVA capacity increases, by the same time the short circuit current is also increasing. It means the fault level is very high. Now come to the next part, sixth, fifth, sixth, seventh one. Okay. Now come to the eighth one. That is your voltage regulation. So voltage regulation, beta, in case of series subtractive polarity, the formula is not valid. For that you have to go by the traditional one. Okay, so conventional approach for that is the windings are represented to you and accordingly you have to go. Is it okay, Vinayak? In case if you are going with the series subtractive polarity, there is a difference between series additive and series subtractive polarity. All these formulas are only valid for the series additive polarity. The formulas are not valid for the series subtractive polarity. We never use that subtractive polarity. The reason behind that is we are not getting the maximum KVA capacity. Okay, so it is better to go with the maximum KVA capacity. Short circuit current, please observe here, the per unit short circuit current is very high in case of a auto transformer compared to two winding transformer when the same two winding transformer is connected as auto transformer, because of the fact that the percentage impedance is lower. Is it okay? So short circuit current is inversely proportional to the percentage impedance. Percentage impedance is decreasing and therefore your this per unit short circuit current is increasing. Is it okay? So it means fault level is increasing. If we have a two winding transformer designed for certain fault level and just by connecting the two winding transformer as auto transformer, then the fault level is increases to much higher value. For that the protection is not designed. That is why we never connect a two winding transformer as a auto transformer. Whenever we have to design a auto transformer, we always select a new auto transformer to fresh transformer to design as auto transformer, because we have to calculate this per unit short circuit current and accordingly we have to design a protective devices. मेरी बात clear है क्या? बढ़िया. Come to the voltage regulation of auto transformer. Voltage regulation of auto transformer to voltage regulation of two winding transformer. Voltage regulation is proportional to percentage impedance. So you can just say, sir, and percentage impedance is KVA of two winding to KVA of auto. So KVA of two winding to KVA of auto transformer. Is it okay? Yes, sir. Now these are the some important relationships that you have to remember for auto transformer. Hoping now each and everything you are recalling very fast. Come to the second, third, fourth part, that is three-phase transformer. Now come to the three-phase transformer. 12th one is your three-phase transformer. Is it okay? Now come to the three-phase transformer. Three-phase transformer can be designed in two ways: a single unit of a three-phase transformer, or three single-phase transformers can be connected in a three-phase configuration. In a three-phase, first of all, you have to remember about the star and delta. In case of star connection, always remember here that in case of star connection, you have to remember about the phase voltage, line voltage, and phase current, line current. Most of the time the numericals will be based on this only. So this will be your line, this will be your phase, and the current in the winding is called as phase current, and current supplied by the line is called line current. So always remember, in case of star, phase voltage is equals to root 3 times of you can say line voltage is equals to root 3 times of phase voltage. Line voltage is equals to root 3 times of phase voltage, and line current is the same as phase current. Okay, now come to the delta connection. Please see here, delta connection. In case of delta connection, you have to remember these things. Please see, the connection will be represented in this format. Okay, sir. So the voltage between line to line is your line voltage. The voltage appearing across the windings is your phase voltage of the transformer. The current supplied by the line is your line current, and the current in the windings of the transformer is a phase current. So here you have to remember that line voltage is equals to phase voltage and line current is equals to √3 times of phase current. Is it okay? Lead and lag depends upon the connection. Is it okay? बढ़िया. अब देखते जाओ जरा. Sir, we have now about the star and about the delta. Now come to the next part. Please see. So till now we have completed about the three-phase connection and slight portion of the harmonics. So I am taking this revision up to the slight portion of the harmonics. Is it okay? बढ़िया. Sir, मजा आ रहा है? ठीक है? बढ़िया sir जी. Now please see. Some very important things that we always remember that in case of a three-phase connections, the possible connections are star. The possible connections can be represented in this way. Please see. I am writing here as a group or a type of connections. Say type of connections. Type phasor group. Okay, and connections and special connections. Okay, so type 1 phasor group is your 0, connections are star 0 and delta 0, and special connections are delta zigzag star. Delta star zigzag. Okay, second one is type 2 connection, 180-degree connection. In that you have to remember about star 6 and delta 6. Okay, the special connections are delta zigzag star. बताओ भाई. ठीक है. Third one is your 30-degree lag, that is star delta 1 and delta star 1. इसमें आता है आपका star zigzag connection. Star zigzag. Okay, always the secondary one is zigzag, secondary one is in star. So in a zigzag connection, basically the transformer secondary is divided into two equal parts. So all the windings are divided into two equal parts and the connection in such a fashion that co-phasal voltages are going to be cancelled out. Come to the fourth part, that is your 30-degree lead phasor group. 30-degree lead phasor group is star delta 11 and delta star 11. So again the special connection possible here is star zigzag star. Okay, बढ़िया sir ji. Good sir, thank you beta. Now come to the next part. I am hoping कि पूरा आपको बढ़िया से recall हुआ है. Come to the next part. So sir, how to go with the different connections? Always remember here that the first part is representing HV, the second part is representing LV, and 0 is representing the phase displacement between line to line voltages of HV and LV. Is it okay? Okay sir. Now please see, I am writing here, just drawing a basic one, so it covers each and everything. Please see here. Here I am writing the connection, phasor diagram for the connection, and phasor diagram for the connection, and some important relations. Now please see. First I am writing here as a star. Please see beta, please see. एक और बना लेता हूँ. Now please observe here. The first one is your star 0 connection. For star 0 connection, you have to first take a neutral point here. Okay, then you have to draw a 12 o'clock position as HV A phase, and then 120-degree apart from this draw B phase, and 120-degree apart from this draw C phase. Keep the phase sequence A, B, C. This is representing A, B, C as a phase sequence. Okay, and sir, the line to line voltage is your VA minus VB. If this is VB, then you can represent V minus VB here, and the phasor sum of this is VAB. That can be represented here also, so we can represent it here. Please see, this will be your line to line voltage V capital AB. Okay, Again, I am taking the same neutral as a reference. Then always remember induced EMFs are in the same phase. So draw a line parallel to A phase. This line is in parallel to A phase only when this terminal is A2 and this terminal is A1. For that, you have to keep one thing in mind, that for HV side, A phase is brought out from terminal A2. Similarly, B phase is brought out from terminal B2 and C phase is brought out from terminal C2. So 120 degree apart from this, you have to draw a line. Okay, keeping in mind that the phase voltages are being time displaced by 120 degree, draw a line 120 degree displaced from this. Now identify this line is in parallel to, this line is in parallel to B phase only when this terminal is B2 and this terminal is B1. Similarly, this terminal is C2 and this terminal is C1. So you can say, sir, small a phase is brought out from A2, small b phase is brought out from B2 and small c phase is brought out from C2. This is representing that the line to line voltage is this. Please see, you have to follow this. V small ab. आप कह सकते हो sir, it means the line to line voltages are in phase. Yes, the line to line voltages are in phase. They are 0 degree displaced. Capital VAB and small VAB are in phase. Only the difference is in the magnitude. So line to line voltages are in phase. Either you can show VAB, VBC or VCA, anyone. If you have three transformers or you have a number of transformers, then you can find the connections in this way. Please observe here. We have the transformer here, and after conducting a polarity test in case of three different transformer, we know about the A2, A1. Capital are representing HV side while small is representing LV side. The phasor diagram suggests us how to connect the connections of three phase in order to get a star star zero connection. Please see here, A1, B1, C1 are shorted, A phase, B phase, C phase. However, here A1, B1, C1 are shorted, small a phase, small b phase and small C phase. So in this case, the induced the terminal voltages VAB capital and VAB small are in phase parameters. You can say, sir, VAB capital here and VAB small are in phase. It means these two voltages are being 0 degree displaced. Is it okay? Acha ji sir. Rest you can easily go with that. Now come to the next part. Is it okay? Similarly, you can go with for the third. You can go with for the star star zero connection, star star 1 connection. Sorry, star delta 1 connection, star delta 11 connection. Is it okay? Up to this, I am hoping each and everything is clear. क्या मेरी बात अच्छे से समझ में आई है? So now you know about the different connections also. So sir, we have star 6 connection. I am just drawing the phasor diagram only. Rest you know. So for that, take this neutral, keep HV at 12 o'clock. A phase is brought out terminal A2, so B phase, and then 120 degree apart is your C phase. Keep the phase sequence A, B, C. So this will be your B2, B1, and this will be your C2, C1. Yes, beta, please tell me. DD 180 connection. Yes, of course, I am just showing you DD 180 also. Please observe first the star 6 connection. Okay, so star 6 connection is your star 180 also. It is also called as star 180. Please see here, A phase, B phase and C phase. Keep the phase sequence A, B and C. Again, take this neutral. If HV side A phase is at somewhere here, then LV side A phase at the same time is at 6 o'clock. Okay, so I am representing A here, but the induced EMFs are in phase, so draw a line in parallel to A phase. The line is said to be in parallel to A phase only the arrow tip is upward, and that can be represented as A2, A1. Is it okay? Now keeping in mind that LV side is in star, draw a line 180 degree displaced, 120 degree displaced from A phase, and then draw a line 120 degrees displaced from this. All the phases are identical in a 3-phase transformer, so you have to keep that thing in your mind. All the phases are identical in every respect. Okay, so the length of each of the line is same. Now if this is your A phase, then this is your A phase. Keeping in mind that parallel lines represent in phase parameter, identify this line is in parallel to B phase when this terminal is B2 and this terminal is B1. Similarly, identify this line is in parallel to C phase when this terminal is C2 and this terminal is C1. Now always remember induced EMFs are in phase parameter. The difference is only in the line to line voltages. So please observe here line to line. You can say, sir, B to A, VAB this, and A phase is brought out from A1, so B phase is brought out from B1, and C phase is brought out from C2. B to A, you can represent here, this will be your V small AB. So it can be understood that VAB capital and VAB small are being 180 degree displaced. Is it okay? So VAB small is 180 degree displaced from VAB capital. That is why this connection belongs to 180 degree phasor. Please मुझे बताइएगा बेटा. बढ़िया. यहां तक मेरी बात क्लियर है क्या? Someone Vinayak is asking about delta 60 is not going to be the any connection beta, because always remember induced EMFs are in the same phase. Why we are getting this? This is because of the fact that, see, if we have a 3 different transformer, then after performing the polarity test on each of the transformer, we can mark the dots. Okay, so dots are represented, let us suppose, by suffix 2. So here 2. Similarly for transformer B, you can say B2 B1 and C2 C1 as small c2 c1. Now please observe here. If you observe the connection, you will come to know what are the different connections possible. Here A1 B1 C1 can be shorted by an external wire and the terminals available as A B C. Is it okay? If you observe here, then A2 B2 C2 are shorted in order to get 180 degree phase displacement. So if you are shorting A2 B2 C2, then this will be your A, B and C. Now please observe, at the instant when this plus minus is increasing, at the same time this plus minus is increasing, so VAB negative increasing at the time when VAB positive is increasing. That is why the voltage difference between line to line is 180 degree. So if you are representing VAB capital in this way, then VAB small is going in this way. Is it okay? That is why I am saying that angle difference between these two are 180 degree. The basic difference is this. That is why this will be your 0 degree. If you observe here, the dots and dots are here. Okay, so the way of connection is going to change the phases. So we can't get delta delta 60. We can only get delta delta 0 or delta delta 180. Is it okay, Vinayak? Badhiya. So I am hoping up to this everything is clear to you. Okay, one more thing. Till now I have completed the basic portion of the non-linearities also. So that I am also going to discuss here. The two types of non-linearities are present in the transformer. That is, saturation and hysteresis. If we talk about the saturation and hysteresis, then in order to get the sinusoidal induced EMF, that is the main desire for any transformer. So in order to get the sinusoidal induced EMF, flux must be sinusoidal, and for that current must be non-sinusoidal and peaky in nature, containing enhancing third harmonic component. Is it okay? But the third harmonic current component is not allowed to flow in the transmission line, because they are going to create a communication interference, objectionable communication interference. If we are not giving third harmonic current, then the current will be sinusoidal. That will create a flat top flux containing depressing third harmonic flux, which creates peaky induced EMF, which is resulting oscillating neutral. So up to now I have completed oscillating neutral point in case of a star-star connection. Okay, and that is because of the co-phasal third harmonics. Is it okay? तो आई एम होपिंग कि आपको यहां तक पूरा रिवीजन अच्छे से समझ में आया है. आज का रिवीजन आपको अच्छे से समझ में आया है? एक बार जल्दी से थंब बना के बता दीजिए. हाँ जी, क्या आपको अच्छे से मेरा रिवीजन समझ में आया है पूरा यहां तक? अगर आपने पूरा ट्रांसफॉर्मर मेरा फॉलो किया है अप टू दिस पॉइंट, देन आई एम होपिंग यू हैव द कंप्लीट इंफॉर्मेशन टिल नाउ. Okay, soon we are going to do the numericals also, and when I start numerical I will keep on going with the numericals only. Up to this everything is okay? सर एक बार हिंदी में बोल दीजिए ना यही लाइन. ईशान बेटा हिंदी में भी बोल देता हूँ, ठीक है. मैंने ये कहा था, इसलिए मुझे हंसी आ गई कि मतलब आपने ऐसे बोला ना, तो इस पे मुझे हंसी आ गई. मैं भी अपने सर से ऐसे ही बोलता था. तो जब मुझे समझ में नहीं आता था तो मैं कहता था जिस लैंग्वेज में मुझे आता है मुझे उसी लैंग्वेज में बता दो. तो ठीक है, ध्यान से सुनना. ट्रांसफॉर्मर की अगर नॉन लीनियरिटीज तक मैंने कंप्लीट किया हुआ है। ट्रांसफॉर्मर की नॉन लीनियरिटीज की बात करें तो ट्रांसफॉर्मर में दो तरह की नॉन लीनियरिटी होती है, सैचुरेशन और हिस्टैरिसीस। अगर इनको कंसीडर आउट किया जाए तो जो ट्रांसफॉर्मर द्वारा सबसे प्राइम ऑब्जेक्टिव है वो ये है कि जो सेकेंडरी वोल्टेज है वो साइनोसॉइडल मिलना चाहिए। लेकिन साइनोसॉइडल वोल्टेज मिलने के लिए यानी साइन वेव का वोल्टेज मिलने के लिए, कॉस और साइन सिर्फ आपका फेज डिफरेंस है, शेप सेम है। तो साइन वेव का शेप मिलने के लिए फ्लक्स साइन वेव का होना चाहिए और उसके लिए करंट नॉन साइनोसॉइडल वेव की होनी चाहिए। ये सैचुरेशन बताता है, जो कि पीकी नेचर की होनी चाहिए। पीकी नेचर की जो करंट होती है उसमें थर्ड हार्मोनिक बहुत अधिक होता है, थर्ड हार्मोनिक को फेजल होता है, जिसकी वजह से कम्युनिकेशन, ऑब्जेक्शनेबल कम्युनिकेशन जो है वो कम्युनिकेशन इंटरफेरेंस प्रेजेंट होता है। तो थर्ड हार्मोनिक करंट ट्रांसमिशन लाइन में बहाना अलाउ नहीं है। अगर थर्ड हार्मोनिक करंट हम नहीं बहाएंगे तो फ्लक्स फ्लैट टॉप्ड नेचर का बनेगा, ऐसा मैग्नेटाइजेशन कर्व हमें सजेस्ट करता है। ठीक है, अगर हम स्लाइड सैचुरेशन में ट्रांसफॉर्मर को ऑपरेट करा रहे तो ऐसी कंडीशन में हमारा जो फ्लक्स, जो इंड्यूस्ड ईएमएफ होगा वो पीकी नेचर का होगा। पीकी नेचर का इंड्यूस्ड ईएमएफ को फेजल इंड्यूस्ड ईएमएफ की वजह से, को फेजल हार्मोनिक इंड्यूस्ड ईएमएफ की वजह से बनता है। ठीक है, और इसकी वजह से ऑसिलेटिंग न्यूट्रल की समस्या आती है। यहां तक मैं आपको बता चुका हूं। सो होपिंग यू हैव एंजॉयड अप टू दिस पार्ट। हाँ जी, बहुत बढ़िया। सो सर स्पीड बढ़ाने की टेक्निक बताएं प्लीज, टाइम टेबल से बहुत पीछे चल रहा हूं। अरे बेटा तुमको दिखाया ना मैं, अभी बहुत टाइम है, एक महीने का टाइम सफिशिएंट है। यू हैव टू फॉलो विद द उम्मीद बैच, दैट इज सफिशिएंट फॉर यू। ओके, सो इफ यू हैव स्टिल स्टार्टेड एंड यू वांट टू कवर इंटायर सिलेबस in 1 month, you can go with the Umeed batch. Soon Umeed batch is going to start, that is on 28th of December. Okay, बहुत बढ़िया। चलो बेटा, यहां तक मेरी बात अच्छे से समझ में आई होगी। आई एम होपिंग यू हैव एंजॉयड टुडेज लेक्चर। जरा देख लेते हैं थोड़ा कुछ बातें और भी जो मैं आपको बताना चाह रहा था। आई एम रनिंग वन सीरीज और इस सीरीज का नाम है ट्रांसफॉर्मर न्यूमेरिकल सीरीज। ये 16 तारीख से स्टार्ट हो चुकी है, ऑलरेडी 5 लेक्चर्स इसके हो चुके हैं। दिस इज इन हिंदी, हाउएवर इट इज यूजफुल फॉर बोथ द स्टूडेंट्स, दोज हु आर इन कंफर्टेबल इन हिंदी एज वेल एज इन इंग्लिश। सो आपको ये ट्रांसफॉर्मर न्यूमेरिकल सीरीज फॉलो करने के लिए बहुत सिंपल से स्टेप्स फॉलो करने हैं। क्या करना है, बस अनअकैडमी का लर्निंग ऐप डाउनलोड कर लेना है। डाउनलोड कर लेने के बाद गेट और ईएससी सेक्शन चूज कर लेना है। आपको फ्री क्लासेस भी मिल जाती हैं, तो ये फ्री क्लासेस में से ही क्लास है, ये आपको ये फ्री क्लास के रूप में मिलेगा। ठीक है, इस क्लास का जो भी लिंक होता है वो मैं पोस्ट कर देता हूं हमेशा इस टेलीग्राम लिंक पे। अब आपको अगर अनअकैडमी पे मुझे फॉलो करना है, then you can go and follow me here as unacademy.com/@machine.work. So you can easily follow me on Unacademy app. Okay, यहाँ पर आपको जो है इस वाले चैनल पे आपको सारी क्लासेस का अपडेट मिल जाता है। प्लीज आप इस चैनल को, टेलीग्राम चैनल को सब्सक्राइब कर लीजिए। See, you are going to get the complete package to crack GATE and ESE. All different and big educators are available here for the different subjects. Okay, hoping you have enjoyed today's lecture. These are some more channels which we have. You can go and follow these channels also in order to get the more technical informations like electrical junction, Unacademy GATE questions, engineering पाठशाला and Kreatryx GATE and ESE. इस पे तो आप देख ही रहे हो अभी। Okay, so hoping you have enjoyed today's lecture. ठीक है सर, तो देखिए बेटा ये हमारा पूरा था आज का। आई एम होपिंग यू हैव एंजॉयड टुडेज लेक्चर। थैंक यू, थैंक यू, थैंक यू। अगर आप कुछ पूछना चाहो तो वो मुझसे आप पूछ सकते हो। अगर आप मुझसे कुछ भी पूछना चाहो तो वो आप मुझसे पूछ सकते हो। ठीक है, मैं आपका कमेंट सेक्शन अभी भी देख रहा हूं, तो अगर आपको कुछ भी पूछना है, इफ यू वांट टू आस्क एनीथिंग देन यू कैन आस्क मी। ओके, अभी तक आई हैव जस्ट कंप्लीटेड द रिवीजन अप टू द पोर्शन विच आई हैव कंप्लीटेड इन द पास्ट क्लासेस। ओके, कोई कुछ लिख रहा है? बहुत बढ़िया. Only believe in content, okay, and be emotionless whenever you are in the study period. Always be emotionless. Thank you.